gentlemen, good day, Algebra. We are going over CO33, which is solving compound inequalities, okay? Because with inequalities, we know that the whole deal with inequalities, you've got several solutions, right? You've got a range of answers that could be correct, okay? But oftentimes, a range of answers not only has a beginning, but it has an end, okay? And that's what compound inequalities show us. So, in theory, there are no limits with inequalities. When we say that we must identify the range of answers because there's an infinite number of solutions if, say, n is greater than 2. Okay? But there are often limits. For example, the stages of water. Cole, Will, please stop talking. At what temperatures is water a liquid? At what temperatures is water in liquid form? Nathan, your hand was up first.
33 degrees.
What about 32.1?
Yes. No.
I don't
Yes.
Right? Doesn't it freeze at 32?
Yes.
Okay. So we can say that the water is a liquid at, I should say temperature, when the temperature is greater than or equal to 32.
It can't be equal.
Or it should just be greater than.
It's just greater than.
Greater than 32. Okay? Does that mean that at any temperature greater than 32, water is a liquid?
No.
No. At what temperature does it become a gas? Briggs?
100 degrees Celsius.
100 degrees Celsius. We're dealing with Fahrenheit here. So does anyone know the temperature in Fahrenheit? Maddie?
Wait, I was saying. That's probably wrong.
Will?
It's 209 degrees.
Nah, a little more than that. Close though. Garrison?
221.
Nope. Got the right numbers, just the wrong order. Cole?
220.
Nope.
220.
Nathan? No. What is no? Kevin?
212.
212.
Good job, guys.
Okay. So, water is a liquid when the temperature is greater than 32 and less than 212. Okay?
This is Fahrenheit.
This is Fahrenheit. Maddie, Paisley, I need you two to stop.
I got my question.
I need you to stop. Nathan,
There's still an infinite number of possibilities.
how so?
Because decimals can't.
Well, isn't that what inequality says, though? Anything greater than 32, including all decimals, fractions, all that stuff, right? Okay, but there's an infinite number of solutions, but it does have a limit. The temperature has to be greater than 32 and less than 212. Rather than writing two inequalities for this, we can write what's called a compound inequality and take care of both limits at the same time. Okay? And how it would look is writing that 32 is less than t, because remember, t is greater than 32 can be rewritten as 32 is less than t, is less than 212. Okay? Essentially saying that t is between 32 and 212. So any temperature between those limits is going to be in liquid state. On a graph, what this looks like is we have two reference points. We plot both 32 and 212. What type of circle would go above each of them?
Open.
Open circles. And what do you think we do?
Forwards and backwards.
Connect them,
Oh. No.
right? So on a number line, what that's showing is that between 32 and 212 degrees, that's the liquid state of water. Okay? Oh, I can do this down here. Sorry, how we show this on a graph? I didn't read my own work here. If it's kind of smushed for work, you can do it down here. I'm rewriting the inequality that I showed up above. Okay? In between 32 and 212 is the state at which water is a liquid. Right? The next one. At what temperatures is water not a liquid? When is it a solid?
32.
T is less than 32. T is
32.
So you are correct. Although in this case, we are going to need to utilize that less than or equal to, right? Because at 32 degrees, that's when water freezes. Okay. So when the temperature is less than or equal to 32 degrees, and then Jocelyn also said, or if T is greater than or equal to 212 degrees. Okay? And notice the use of the word or there. Right? Because what word, I didn't write down here, what word did we use to describe when it was a liquid? When the temperature is greater than 32 and less than 212. Okay? I'm going to highlight this. Nathan, that's enough. Right? Water is a liquid when the temperature is greater than 32 and less than 212. Two conditions must be met. Greater than 32 and less than 212. In this case, though, it's an or statement. It can't be less than or equal to 32 and greater than 212. Doesn't make any sense. It's going to be one or the other. And so the graph of this is going to look, this is called an or statement. T is less than or equal to 32, or T is greater than or equal to 212. The graph of this still gets both numbers plotted on a number line. What type of circles will be above each of them? Closed. And we're not going to connect them, because if we connected them, that means it's between. In this case, they're going away from each other, outward. Okay? So we have two types of compound inequalities. One is an and statement. The and statement will always look like this, connected, because two things must be true. Okay? Greater than 32 and less than 212. An or statement will always look like this, where they're going opposite directions away from each other, because only one thing must be true. Less than or equal to 32 or greater than or equal to 212. Okay? You see the difference?
Yes.
Okay. All right. So down below, we get a little bit some solving here. It says solve each component inequality and graph your solution. Checking your work. I'll talk about how to do that in just a little bit. This first one here, what is it set up as? And or? An and. Okay. X is between two values. So on the number line, there's nothing to solve for because X is already by itself. We're going to plot negative 11, plot positive 14. What type of circles above each of them? Open. And if X is between negative 11 and 14, we show that by connecting them. Right? That's it. Okay. Nathan, give me a value for X that should work. 13. And we know that because 13 is between negative 11 and 14. If we plug in 13 into this inequality, negative 11 is less than 13. Is that true? Is 13 less than 14?
Yes.
Yes, so it works. Okay? If we pick something outside of the range, say we pick 16, is negative 11 less than 16? Is 16 less than 14? No. Right? Two conditions must be met for an and statement to work. Okay? The next one. Is it an and statement or an or statement?
Or I think.
How could you tell?
I
know,
know.
Maybe it's just a big or.
It literally has the word or in it. Okay? X is less than 5 or X is greater than 15. On the number line. 5 and 15 get plotted. What type of circles go above each of them? Open. Which direction on the 5? Left. Which direction on the 15?
That way.
Right. Okay. Give me a solution to this inequality, Cole.
14.
14. 14 is not in our solution set. Okay. If we test that, is 14 less than 5?
No.
Is 14 greater than 15? Neither of them work. And they shouldn't because 14 is not in our solution set. Cole, give it another try.
4.
4. Is 4 less than 5? Yes. Is 4 greater than 15? No. Is that okay?
Yes.
Because or. Only one of them needs to work. An and statement, they both need to work. An or statement, only one of them needs to work. Okay? If neither of them works, well then you know you're in the non-solution set. Okay? What if we've got other stuff in between our two values here? 18 is less than or equal to x minus 3, which is less than 32. What do you suppose we do there? Yeah. Not quite simplify. We're going to be solving. So we want to get x by itself. What do you think? Subtract or add 3? Whenever we solve something, opposite operations. Okay. Since we're subtracting 3 from x, to undo that, we're going to add 3. And in this case, because we have like 3 parts to the inequality, 3 sides, so to speak, we have to add 3 to all 3. 18 plus 3, x minus 3 plus 3, 32 plus 3. Okay? Because adding 3 is going to cancel that out and give us x in the middle, which is what we want there, right? But we also have to add 3 then to both values on the outside. And we get 21 and 35. What type of statement is this? And statement, because x is between 21 and 35. We don't plot our original values there, right? We rewrote the inequality to get x by itself. So 21 and 35. What goes above the 21? Closed. What goes above the 35? Open. How does the lines look? Whatever. Connected. Okay? Because it's an and statement. Give me a number in our solution set. Will.
22.
Sorry?
22.
22? So 22, we go back to our original inequality. 18 is less than or equal to 22 minus 3, which is less than 32. Here's where we'd simplify. 22 minus 3 is 19. Is 18 less than or equal to 19?
Yes.
Is 19 less than 32?
Yes.
Yes. Okay? Go back to that original inequality and plug it in. When you have an or statement, next one. Since only one of them needs to work, they're not really connected, you actually solve each of these separately. Okay? You can think about them as 2 separate inequalities that you're just graphing on the same number line. So in this first one, what would our first step be here? Again, just focus on this one. We're solving them separately. What do we do first? Add 5 to both sides. Exactly. Opposite operations. That gives us 2x is less than 2. Now, it is a solution. X is less than 1. Yeah, real. Right? You're just solving a 2-step inequality here. Same as solving a 2-step equation, only if you divide by a negative number, you got to watch out for all those steps. But yeah. Okay? And then the other one, what do we do first there? Subtract 1. X is greater than 10. And then? Divide by 3. It doesn't work out. That's okay.
You were mad at us, everybody. Prepared.
Why are you mad at us?
Okay? X is greater than 10/3. Sam, turn around. Nick?
Are you still mad at yourself?
Oh, this isn't bad. 10/3 isn't bad.
But no, what were you still mad at?
Probably. Graphing this now, I didn't leave a lot of room for my graph, but hopefully you've got some more space on your page.
Yep.
It is an or statement, right? And so you know that it's going to look like an or statement. You've got 1 and 10/3 plotted. Open circles above each of them. One going left, the other going right. Okay? Questions on this? Nick? Okay, Cole?
Is the second thing gonna be homework?
No homework for tomorrow. We'll pick up with this again tomorrow.
So we don't have to thank you guys.
We do not have any homework for tonight other than math back into tomorrow on Thursday. That's how you math.